Hi everybody, how are you today? Today we're going to be solving a system of equations graphically. This may sound familiar to you because when we have solved equations, we have had three different types of solutions. Well, it's the same thing when we solve a system of equations. And all that really means is that we are now going to be working with two equations that we will be graphing on a coordinate grid together. That's all that means. When I graph those two equations on a coordinate grid, I can get one of three types of solutions. First type is one solution. That is when these two lines cross at one point. Hence, there is only one solution, so that makes sense. The second type of solution we have is infinitely many. Infinitely many just means we have two lines that actually coincide or sit on top of each other. Last but not least, we have no solution, and that will look like two parallel lines. And that makes sense because two parallel lines never meet. So hence, there would be no solution. So let's go ahead and summarize that in a chart that I have for you. Let me just move that down. There it is. Systems of equations. We're going to go ahead and fill this in. First of all, the type of solutions that we have is we have one solution, which looks like two intersecting lines. And they will meet only at one point. We will then have infinitely many solutions as another possible solution. Infinitely many will look like two lines that coincide. Oh gee, that's terrible. Coincide, if I can get this to, oh gee, it doesn't want to work. Okay, there it goes. Just means two lines that actually sit on top of each other. Then we have no solution. Oh gee, it's doing it again. There we go. And all that no solution looks like is two parallel lines, which are two lines that never meet. So go ahead and fill that into your chart as kind of a summary of what we just talked about. And now we're going to go ahead and take a look at what they look like when they're given to us as equations. Sorry about this. I still have to scan this thing down and it's a pain. There we go. Yay! All right, let's take a look at the first one. The first one says some systems have no solutions. Example, parallel lines that never intersect. We're going to take a look at these two equations. It says for the equations written on the lines to the left, rewrite each equation in slope-intercept form. Remember, that means it has to look like y equals mx plus b. And this is very important to understand, is that any time we are graphing a system of equations, they have to be in y equals mx plus b form. So not only we can graph them correctly, but so we can look at them and identify what is the same and what's different to figure out how many solutions we have. So let's take a look at our first equation. It's negative 2x plus 4y equals 4. Well, remember, we need to isolate the y or get the y by itself. So we're going to start by adding 2x to both sides of the equal sign. These zero out. I'm left with 4y equals, and remember, mx plus b shows us that we write our x's first. So 2x plus 4. I'm then going to go ahead and divide each term by 4. That's a fancy form of 1. I get y equals, let's simplify 2/4 to 1/2. X plus 4 divided by 4 is 1. So that's how you would rewrite that equation. So this line right here can be rewritten as y equals 1/2 x plus 1. And it's a beautiful positive slope, so it's going uphill left to right. Now we're going to look at our other equation, which is x minus 2y equals 6. First thing we have to do is get the y by itself. So we're going to subtract the x from both sides. We then zero those out, have a negative 2y equals, remember we write our x's first, so negative x plus 6. We're then going to divide each term by a negative 2. Fancy form of 1 over here, so we have y equals, ooh, there's a a 1 in front of that x. So what's a negative divided by a negative? It's a positive. So that becomes 1/2 x. And a positive divided by a negative is a negative 3. Let's take a look at those equations, because then it says, what do you notice about the equations after they were rewritten? Notice what's the same and what's different when we have no solution. Well, the slope is the same, but, and this is so important, this is why there's no solution, the y-intercept, and I'm just abbreviating, is different. That is how you will know there is no solution. Oh, gee, this pen is not connecting. There we go. That is how you'll know there is no solution when you are given two equations. The slope is the same, but the y-intercept is different. And doesn't that make sense? Isn't the steepness of those lines exactly the same? Yes, but don't they cross the y-intercept at a different point? Yes, so that totally makes sense. Let's go ahead and move on to the next type. Once again, oh gee, bear with me. Bear with me, everyone. Oh gee, oh gee. There we go. Okay, there it goes. There it goes. It's moving. That makes me happy. Now we're going to look at infinitely many solutions. First of all, let's take a look at these two equations. The one line, and you may not be able to see it, but the one line is purple, okay? And that equation looks like y equals 2/3 x plus 2. The other line, which is in black, is y equals 2/3 x plus 2. Well, what do you notice about the two equations when written in y equals mx plus b form? They are exactly the same. Now remember, when we start, if we have to rewrite them, they may not look the same. But as soon as you put them in y equals mx plus b form, if they look exactly the same, then there is infinitely many solutions. So remember, this is infinitely many. And they will actually sit right on top of each other, which means they have the same slope, so they have the same steepness, and they have the same y-intercept, which is where they cross the y-axis. So that's infinitely many solutions. One more, and then we are done. Woo, that makes me happy. Okay, here we go, here we go. I'm still trying to move. Oh, gee. There it goes, there it goes. One solution, yay, this is the last one. I'm going to do this one in blue because it makes me happy. It says one solution, which is two lines that intersect at one point. The point of intersection of the two lines, 3, 0, is the solution to the system of equations. This means that 3, 0, when substituted, please underline this, into either equation, will make them both true. What does that even mean? Well, first of all, graphically, it's so easy to see that there's only one solution, because this point where they meet is that one solution. And according to this graph, they meet at 3, 0. That's where they intersect. So let's take a look at 3, 0, because what does that really mean? Well, we know that it's a point on that graph, so we have an x value and a y value. The 3 represents the x, and the 0 represents the y. Let's take a look at the red line. And I'm going to go ahead and do this in red so that it matches. It says 2x plus 2y equals 6. Well, we have an x value, and we have a y value in our solution. So instead of writing an x in our equation, we now know what x is, which is a 3. So we're going to substitute in the 3 for the x. We are then going to go ahead and substitute our y value in, which is 0, for our y in our equation. That's still going to equal 6. Well, what is 2 times 3? It's 6. Plus, what's 2 times 0? It's 0. And guess what? 6 plus 0 equals 6. Does that solution work in that equation? You bet it does. So that is definitely the solution to that first equation. This looks an awful lot like a check. So if you did your checks and understood them, then you should be able to prove that one solution will work. Let's go ahead and take a look at our other equation, which is 4x minus 6y equals 12. Remember, our solution is still 3, 0. And if it is 3, 0, it should work in this equation as well. Here's my x value. Here's my y value. So instead of the x, I'm going to put in my x value of 3. And instead of the y, oh gee, that's supposed to be a 6. I'm going to put in my y value of 0. Gee, that's not writing. There we go. And that should still equal 12. Sorry about that. 4 times 3 is 12, minus 6 times 0, which is 0. And guess what? 12 equals 12. So does that one solution work in both of those equations? Yes. Hence the reason there is only one solution. Now you're going to notice as we continue on, it says the word practice. I am not going to go over those with you, but you can go back and look at these notes to help you with these next 3 practice problems. Remember, if you graph 2 lines that intersect, there's one solution. If you graph 2 lines that sit on top of each other, there's infinitely many solutions. And if you graph 2 lines that never meet and are parallel, then that means there is no solution. Always remember, you have to write them in y equals mx plus b format before you graph them. So please make sure you do that step first. Good luck. We'll be around to help you out. Shout out to Mr. U. I hope your English class is as fun as math. Bye-bye.
Oh, no way.
No way is right.